In my earlier video, I had discussed about span of a vector space. Today I will discuss new and interesting topic, linearly dependence and independence of a vector space. Actual goal of this lecture is linearly dependence and independence of vectors. Consider two vectors. A1 equal to 3, 1, 6. Consider this is the A1 vector. And A2 equal to 4, 2, 0. Is A2 is same line? No. This is A2 not be dependent in A1. So this is different vector. Consider this is A2. Actually, span of A1, A2 is the plane in the space R2. Consider other vector A3 equal to 6, 3, 5. This is also not dependent A1 and A2. So, this is another vector and span of A1, A2 and A3 be the whole R3. But consider A4 equal to 840, then A4 is dependent in A2. And this is the idea of linear dependence. These two vectors actually the same line. So, span of A2 and A4 be actually line. This is our first goal of this lecture. How I will find linear dependence and independence of vectors. It is very important, not only vector space, metric space, topological space, so on. Then our next goal of this lecture is solution of the equation Ax equal to b, where A be any matrices. And how we have to find the solution of this equation, this is very important for IIT exam, CSIR net, GATE, for all competitive exam. These two our goal of this lecture. See, at first the first goal of this lecture, linearly dependence and independence of vectors. To find the linearly dependence and independence vector easily, at first just consider two vectors. At first consider two vector v1, v2. When the vector v1 is multiple of v2 or vice versa, then the set containing the vector v1, v2 will be linearly dependent. When the vector is not multiple of other, at first consider two vectors. Let's suppose we have a solution to the vector equation x1 v1 plus x2 v2 equal to 0 vector. And consider x1 equal to c and x2 equal to d for some c and d. Then the equation will be replaced cv1 plus dv2 equal to 0 vector. If c not equal to 0, then the vector v1 equal to minus d over c times v2. But v1 is not multiple of v2. So, our assumption is a wrong assumption. Obviously, c must be equal to 0. Similarly, obviously, d equal to 0. Both c and d equal to 0. Here I have started with arbitrary solution. And always this solution has a trivial solution. And this is the idea of linearly independence of vector. Therefore, actual idea of linearly independent and linearly dependent is a collection of vectors is either linearly independent or linearly dependent when the vectors v1, v2 up to vn are linearly independent if the equation involving the linear combination a1 v1 plus a2 v2 up to n vn equal to 0. And this is true for linearly independent every scalar equal to 0. That means ai equal to 0 for all I equal to 1 to n. And when the vector v1, v2, vn are linearly dependent, then if the equation has a solution when at least one of the scalar is not equal to 0. Are you getting the idea? Next goal is solution of the equation ax equal to b. For this solution, at first recall the span of S. We all of us know span of S is the set which be the linear combination of all vector in the set S. This is the, if S contain v1, v2, vk vector, then span of S be the linear combination of v1, v2, vk vector. Consider as for example, S contain x1 vector and x2 vector, where x1 equal to 1, 0, 1 and x2 equal to 1, 1, 0. Then what would be the span of S? Consider B belongs to span of S such that B equal to alpha 1 x1 plus alpha 2 x2. Here just put the value. From this equation we can write Ax equal to B, where A be the 3 cross 2 matrices and X be the vector alpha who is contain alpha 1, alpha 2, and here B contain B1, B2, B3. Then we can write this as first type. This is A, this is X and this is the vector B. Okay. Just recall another way to writing the system of equation. We all of us know this is the system of equation X equal to B, denoted as another way of writing X equal to B, this equation as, consider the A as column of A are here A1, A2 up to AN. Then we can write it as x1 times A1 plus x2 times A2 up to xn times AN equal to B vector. I have write this as such type. Okay, because this is and these are both similar. Here notice the vector B is a linear combination of column of the matrix A. So the system Ax equal to B has a solution if B is a linear combination of column of the matrix A. That means if B belongs to span of the column vector A1, A2 up to A. Are you getting the method? How we have to find solution of Ax equal to B? And this span is called column space of A. Similarly, the row space of A are span of row of A. This is the very important note. The equation Ax equal to B has a solution only if B lies in the column space of A. I will highly recommend you, please understand when the solution Ax equal to B exists. This is very important for any competitive exam, CSIR, NET, GATE, IT JAM, so on. Solution exists when B lies in the column space of A. Now let's come back our original question. Here we have to find the vector B. Here Ax equal to B means Ax equal to B, this is the non-homogeneous equation. So I will use here the row reduced echelon form. The vector 1, 0, 1, 1, 1, 0 apply with B1, B2, B3. Now I will apply row reduced form. At first R1 equal to R1 minus R2, then R1 replaced by 1 0 b1 minus b2, and r3 equal to minus r1 plus r2 plus r3. Then r3 replaced by 0 0 minus b1 plus b2 plus b3. From this equation we can write minus b1 plus b2 plus b3 equal to 0 vector. That means that imply b2 plus b3 equal to b1. Therefore, the span of S equal to set of those vector in R3 such that x1 equal to x2 plus x3. Have you understood? We will see how we will find linear dependent and independent of vector space. We had seen few minutes ago v1, v2, vm, if these vectors v belongs to Rm, then linearly independent if a1, v1, a2, v2 up to am, vm equal to 0. Here noticeable this vector belongs to Rn, and here the m component. And if linearly independent, then all scalar means a1 up to am equal to 0. And if the vector be linearly independent, since all scalar be equal to 0, that means there exists only one unique solution. But if the vector be linearly dependent, then obviously there exists non-trivial solution, because when linearly dependent, then at least one ai not equal to 0. That means if at least one ai not equal to 0, that implies there exist infinitely many solutions exist. Now let's see how we will find linearly dependence and independence of vector. Here the equation a1 b1 plus a2 b2 plus am vm equal to 0, and this is just like homogeneous equation ax equal to 0, and v1 be the first column vector, v2 be the second column vector, and vm be the mth column vector. And here, since this is equal to 0 vector, that means this is 0, and here the matrix is m cross n matrix, because I have considered v1, v2, vm belongs to Rn, and if one of v1, v2, vm is 0 vector, then the vector is linearly dependent. Also, other, if v1, v2, vm belongs to Rn, and if the number of rows greater than number of column, then the vectors are linearly dependent. Now I will see how we will find linear independence of vector. I will find the linear independence of vector by matrix rank. We all of us know what is the matrix rank. We had studied in 12th standard matrix rank. Actually, matrix rank allows to determine the maximal number of linearly independent rows or column of given matrices. Actually, today's topic is more important for any competitive exam. If you understand this part clearly, then it will be more easy to verify the solution of homogeneous equation. Because in homogeneous equation, when unique solution exists, when infinitely many solutions exist, this part is very important for CSIR net, GATE, for any competitive exam. So I will highly recommend you, please understand this part with pay attention. And if you have any queries about this part, then please do comment in comments box. Determine the vector, the set containing the element 1, 3, minus 1, 4, 4, 0, 5, 1, 2. Let's say, is the vector is linearly dependent or linearly independent? To find the linearly dependent or independent, we have to check C1 1 3 minus 1 plus C2 4 4 0 plus C3 5 1 2 equal to 0 vector. And this is actually reduces the equation Ax equal to 0, homogeneous equation, where A be the 1 3 minus 1 4 4 0 5 1 2. Now I will find the rank of this matrix. To find is the vector is linearly dependent or independent. To find the rank, at first apply row reduction from. First I will try, here 3 would be 0. Now apply the operation R2 equal to minus 3R1 plus R2. Then R2 replaces 0 minus 8 minus 14. It is here minus 1 and here 1. To find row equivalent from, that means here to 0, to reduce 0, apply R3 equal to R1 plus R3. Then R3 would be replaced 0 4 7. Here notice one thing, this row and this row is just multiple of 2. So now apply R3 equal to R2 plus 2R3. Then the matrix would be 1 4 5 0 minus 8 minus 14 0 0 0. I have got here the 0 0 0 vector. That means the vector obviously linearly dependent. Here the rank of the matrix is true. Just this is the row equivalent from. Just to find the solution, because there exist infinitely many solutions, just divide this part, this row by 8, then this would be reduced as 1 0 minus 2 0 1 7 over 4 0 0 0. Then the solution would be alpha 2 equal to minus 7 over 4 alpha 3 and alpha 1 equal to 2 alpha 3. Here alpha 3 be any arbitrary number. So there exists non-trivial solution. Means our given vector be linearly dependent, and since the vector be linearly dependent, so this homogeneous equation has a infinitely many solution. Are you getting clearly? Oh well. Our next question, the set containing 1 minus x plus 2x square minus 1 plus x square minus 2 minus x plus 5x square is the set is linearly independent of polynomial less than equal to 2. To prove linearly independent or dependent, we need to solve a times 1 minus x plus 2x square plus b times minus 1 plus x square plus c times minus 2 minus x plus 5x square equal to 0. That imply a minus b minus 2c equal to 0, minus a minus c equal to 0, 2a plus b plus 5c equal to 0. These three equations always represent one matrix 1 minus 1 2, minus 1 0 1, minus 2 minus 1 5. Now if we apply row reduction, then at first apply the row reduction from, just apply it own self. Our operation at first R2 replaces R2 plus R1, R3 replaced by R3 minus 2 R1. Then notice here the vector 0 minus 1 minus 3 and here the vector 0 3 9. Then R3 replaced by R3 plus 3 R2. Since here the in equation has only sign minus, so just omit minus 1. Then our original row equivalent from is this. Means this part is 0 vector, so this is the linearly dependent solution. And if we consider c equal to lambda, then a would be minus lambda and b would be minus 3 lambda. Therefore, there exist infinitely many solution exist for arbitrary lambda, and the solution would be minus lambda times minus 1 minus 3 1. Are you getting how we have to find solution of homogeneous equation? This solution is infinitely many solutions. Because here lambda be any real number. Our next question is the set which contain 1 plus x, 1 minus x squared, x plus 2x squared. Is the set is linearly independent in P2R? Similar to before. From this, the matrix would be 0, 1, 1, minus 1, 0, 1, 2, 1, 0. Now, similar to before, if we apply the row reduced equivalent form, then this would be 1, 0, 0, 0, minus 1, 0, 1, 2, minus 1. And notice, here 1, here minus 1, here minus 1. That means, here the rank of the matrix is 3. So, obviously this vector be linearly independent. That means there exists only unique solution. A equal to 0, B equal to 0 and C equal to 0. And this is actually the trivial solution. Are you getting? I will define one another method to find linear dependent and independent of a solution. Here one thing noticeable, here V1, V2, Vm belongs to Rn. Here M vector and this is belongs to Rn. So, reduces matrices is M cross N matrices. And to find the linearly independent, for this I have applied rank. But when the here M cross N, but when the N cross N matrices means square matrices, then to find the linearly independent or dependent, I will apply determinant. The relationship with determinant is to check whether a set of n vectors in Rn are linearly independent. We have to find solution of homogeneous equation where A be n cross n matrices. Here A is a, since square matrices, it has a unique solution when, if and only if determinant of A not equal to 0. That means when determinant of A not equal to 0, then these n vector in Rn are linearly independent. Because when determinant of A not equal to 0, that implies the matrix is invertible. Are you getting? Well. Now, as for example, consider the vector 1, 4, 2, 0, 4, 3, 1, 1, 0, which generate the matrix A. And if you calculate the determinant of this matrix, then determinant of A would be 1, which is not equal to 0. That means obviously A is invertible. And since A is invertible, that means this vector, which will be the column vector of this matrix, obviously linearly independent. This is the another method to check linearly dependent or independent of a vector. But here one thing noticeable, this will be applicable when the matrix is square matrix. Now I will discuss other type of linearly dependent and independent set. Till now I have discussed linearly dependence and independence of a finite set. Now I will discuss about the infinite set. An infinite set is of a vector space V is said to be linearly independent if every finite subset of S is linearly independent. That means an infinite set will be linearly independent when every finite set which contains this vector space obviously will be linearly independent. As for example, consider S contain the element 1, x, x square, x cube. We will prove this set is linearly independent. We have to prove every finite set which contains this set S will be linearly independent. Consider a finite set x, x square, x cube up to x to the power 100. Then to find the linearly independent of this set, consider this set is L. A naught x plus a1 x square plus a2 x cube up to a99 x to the power 100, which is equal to here 0 means 0 polynomial. Now, and if we equal each coefficient, here a naught would be, since here the 0 polynomial, obviously a naught would be 0. Similarly, a1 would be 0, a2 would be 0, so on, a99 would be 0. That means obviously this set L is linearly independent. Similarly, every subset of S will be linearly independent. Are you getting? How we have to find linearly independent set for infinite set? OL. I will stop here. In my next video, I will discuss basis of a vector space. But at first I will highly recommend you, please see today's video with pay attention, because this topic is very important for any competitive exam. See you soon. Stay safe and stay positive always.